Hi, 8th grade. This is lesson 2 of module 10, Investigate Roots. And the I can statement says, I can evaluate square roots and cube roots. If you have not done the Spark Your Learning, pause the video here and go back and do that. It's related to what you're doing here, so it'll be really helpful. Let's look at the build understanding, and then I'll have you pause and work on it on your own before we write it out together. So it says Aaron is planning to make origami cubes. So here's those of different sizes. The edge lengths of the cubes are 1 inch, 2 inches, 3 inches, and 4 inches. So here they want you to write down the formula of a cube. They want you to fill out this table in B. What did you notice about the volume changes as the edge length increases? And then D, if you were given the volume of a cube, how can you find the edge length? So you're kind of working backwards or thinking that way. E, what is the edge length of a cube with a volume of 125 cubic inches? And why is it difficult to express the edge length of a cube with a volume of 10 cubic inches? So pause here, work on those, and then we'll come back and write them out together. All right, so let's look at these together. So A, talk to a partner and write down the formula for the volume of a cube. So this is probably review. I'm sure you've done this before, but if you remember, the volume of a cube is length times width times height. So you can write it that way. Volume equals length times width times height. You can also say that the length times the width is the area of the base, and we write that as a capital B, and then you multiply that times the height. So it's basically the same formula. The other way is oftentimes because the cube has the side lengths all the same measure, you can say that it's the volume equals the side cubed. So let's look at the table. If the edge length is 1, the volume would be 1 times 1 times 1, or 1. If it's 2, 2 times 2 times 2 is 8. 3, it would be 27. And 4 would be 64. 4 times 4 is 16. 16 times 4 is 64. So see, what do you notice about the volume changes as the edge length increases? Well, you can see the edge length is only increasing by 1 each time, but the volume is increasing quite a lot more significantly. So that's one way you could say it. The volume increases much more quickly than the edge length. D, if you are given the volume of a cube, how can you find the edge length? So in this case, you're kind of thinking backwards. You have the volume, and you're trying to figure out what number raised to the power of 3 would give me that volume. So that's what you would put there. You would try to find a number that equals the volume when cubed, or when raised to a power of 3. E, what is the edge length of a cube with a volume of 125 cubic inches? Well, we know that 5 times 5 is 25, and 25 times 5 is 125, so that edge length would be 5 inches. Why is it difficult to express the edge length of a cube with a volume of 10 cubic inches? Well, we know that 10 is not a perfect cube. There's no whole number raised to the power, or no integer that's when it's raised to the power of 3 equals 10. So that would be the reason it would be hard. So no integer that equals 10 when raised to the third power, or raised to, I'll say that, the third power. So if you want to, go ahead and do the turn and talk, and then we'll look at the next page. So on this page, the Step It Out, there's a lot of vocabulary. So what I'd like you to do is pause the video here, read through the vocabulary, and try number 2 on your own, and then we'll come back and look at that together. All right, so let's look at the vocabulary. A lot of this may be review because you've worked with squares and square roots before, but let's look at these words together. So the square root of a positive number p is x when x squared equals p. So, for example, when 3 squared equals 9, the square root of 9 is 3. And what they want you to notice is that for every positive number has 2 square roots. So I can say that positive 3 squared equals 9, and I can also say that negative 3 squared equals 9. And these parentheses here are really important because if I write it this way without the parentheses, it may not be the same because you need those parentheses around the negative 3 saying that you're squaring negative 3. You're not taking the opposite or negative of 3 squared. So that's an important difference. If we look, okay, so the 2 square roots of 9 are 3 and negative 3, and these are sometimes written together like this as plus or minus 3. All right, a perfect square is a whole number whose square roots are integers. For example, 16 is a perfect square since its square roots are the 2 integers 4 and negative 4. The square root of any number that isn't a perfect square is another example of an irrational number. So that's an important thing to remember as well. And this sign or symbol is called the radical symbol. It's used to indicate the positive square or square root or principal square root. So the positive square root is always called the principal square root. So the square root of 16, if it's under that radical sign, equals 4, positive 4. So use the information about roots to evaluate each expression. So here they're saying what squared equals 81 and what squared equals 81. So what you would do in these is you know that 9 times 9 equals 81. And so here you would do the negative 9 in the parentheses. So the square roots of 81 are 9 and negative 9. So here they want you to find the square root of a fraction, which is not so bad if both are perfect squares, both the numerator and denominator. So you would say both, you know, the square root of 4 is 2 and the square root of 9 is 3. So it would be 2/3 squared. And the opposite of that, so you would say, and you can see the little negative sign there. And so there's the other one. The square root symbol indicates the principal square root. So the square root of 4/9 is 2/3. Because that's under that radical sign symbol. So it says, suppose Aaron wants a square piece of origami paper with an area of 2 square centimeters. What is the length of one side of the piece of paper? And they say use a square root symbol in your answer. So you would just write square root of 2 centimeters as your answer. Is 2 a perfect square? No. Why or why not? There is not an integer whose square is 2. Is the square root of 2 rational or irrational? It is irrational. Square root of 2 cannot be written as the ratio of 2 integers. So that's that section 2. I think you probably knew most of those, but that's good review. So that's the end of this lesson. I'll see you in lesson 3.